Awesome. Well, welcome everybody that's joined today. We're so happy you're here with us. If you've never joined Detection Dispatch, this is our live bi-weekly workshop series. We bring in a lot of our internal experts, our subject matter experts as well. And we do technical hands-on sessions. We do Q&As. We'll bring in customers sometimes. So if you've never joined, welcome. Super happy to have you. Today, we have an awesome session with Kevin Zook. He's our threat hunting engineer here at Anvilogic. Really hands-on. We'll have a lab portion that he's prepared for this as well that we'll be giving away at the end. So stay tuned for that. But if you have any questions throughout the session, please feel free to drop them in the chat below, or you can chat me directly and I'll tap Kevin to get your question through to him. So without further ado, I'm going to pass it over to Kevin, let him give a brief intro to himself and kick the session off.
So yeah, this is on Windows lateral movement, how to track it, what it looks like, what it is. I'm Kevin Zook. I'm a threat hunting engineer at Anvilogic, and I've done a bunch of roles in cybersecurity, research, IR, SOC, threat detection, stuff like that, all types of different roles. And I feel like I have something to offer because I've learned a lot in those roles, and I feel like I can show you some stuff that you might not have seen before. So let's go over the goals of this presentation. The goals are to teach you the basics of lateral movement in Windows. It's going to focus heavily on event logs, especially the event logs that are generated by a default install of Windows, because if you've done like IR before, you notice that there's a lot of default builds out there and they're not tweaked very much at a lot of different companies. It's just kind of the path of least resistance. So there's a lot of it out there. It's going to expose you to several different methods of lateral movement and the artifacts generated by them. Again, mostly Windows logs, but a little bit of registry and file system and process where it matters. And I'll tell you when it matters. And at the end, you should be more familiar with what lateral movement is, how to detect it, what it looks like, all that stuff. And you'll get a challenge at the end, which shows a bunch of logs, and you have to match the log to what it shows, like what type of lateral movement it shows. So what is lateral movement? It's basically when an attacker moves between two hosts on the same logical network. It can be accomplished by either like remoting into the machine or just executing commands on it. Because once you can execute commands, you can, download an arbitrary backdoor and have full control if you want. The methods of lateral movement are going to vary based on operating system. You're going to have to look at different logs for each. Like, for example, Linux is very different from Windows, but this presentation is going to focus on Windows since it's just the most common in enterprises. Lateral movement can occur between different OSs and different host types. So you can move between a workstation to a DC if you want. You can move from a DC to a workstation. It just depends on what you're trying to accomplish or what the attacker is trying to accomplish. Lateral movement usually involves a source host and source OS, target host and target OS. And when Windows authentication is involved, like it creates login events, in other words, in a session, it's going to involve a subject and target user. And I'll get into what that is in a little bit. So here's some examples of lateral movement based on, just what I said before. Let's say an attacker compromises a web server that's on a perimeter, and that web server is also on the same network as a domain controller. I've seen attackers use PSExec before to move from the web server to the domain controller just to get more access, maybe steal more creds, and be able to move where they want without restriction. Another example is an attacker moves to an application server using RDP to look for data to steal. I've also seen this many times. Some people just prefer that method of file browsing, the visual method. I've also seen data just stolen through RDP as well. So an attacker deploys a backdoor to 100 workstations from a compromised domain controller using scheduled tasks. This type of scenario would be like ransomware related. They usually put a file somewhere and then tell a whole bunch of hosts to go get it and execute it. This method would apply there. They can use scheduled task or PSExec or something else even, but the one-to-many file deployment scenario using scheduled tasks or anything is really common for ransomware. Last one is an attacker moves from a workstation to a server after deploying a backdoor from a phishing message to obtain more credentials using PowerShell, PS remoting. So those were all examples. This is where you learn about what happened, Windows logs. One of the most helpful sources to determine whether lateral movement happened is in Windows event logs. And this even applies on a machine that just has default settings on it. So it's really important to learn these logs. The types of logs that these are security system and application. Those are the EVTX or EVT files you would be looking at on disk or with the Windows event viewer if you're looking on the same machine, like in a lab or something like that. The most important lateral movement Windows event IDs are 4624 and 4648, and I'll get into what those are. 4648 is generated on the source, and it basically says, I went to another host on the network, it was this host, and I tried to move laterally to it. It doesn't say whether it was successful or not, it just says that it was attempted. To learn whether it was successful or not, you would need to look for a Windows event ID 4624 on the target machine, which shows a successful login, and it shows some details about the lateral movement that'll give you hints in an investigation. Lateral movement logs usually involve a subject user and a target user. So you can be one user and then try to generate a login session on another on a remote machine if you want. And I have a couple ways to look at these event IDs. I've mentioned it before in previous talks I've had, but you can't really beat Microsoft documentation most of the time. So for any of these Windows event IDs, you can go to Microsoft and learn about them. These are all very well documented because they're well known. They're often show up in breaches. Also, a colleague of mine really likes Ultimate Windows Security, which is just another source for this type of information. It really depends on what you're looking for, but this can tell you a little bit more than Microsoft in some cases. So I'd recommend looking at those if you're stuck. Let's keep going here. Okay, so if you're using like Anvilogic or something like that, in order to get this into the detection pipeline, you would need to send Windows IDs 4624 and 4648 to your log stack, and then you would need to also make threat indicators out of them if you wanted to build content based on it. Windows event logs have a .evt or .evtx extension, and they're located at that path there. They can be copied from the host and examined on another host, but Windows logs are in a special format, and you have to have a special tool to interpret it, or just use the built-in Windows event viewer to look at the logs. It can sometimes be a little dicey converting these EVTX into another format, but there's tools out there to do it. So like I said before, you can use Windows Event Viewer on the host if you're in a lab environment or something like that. So EDR events can often be used alongside Windows logs, and they can often be more descriptive about what's happening depending on how the EDR software is generated. So even though this talks about Windows event logs, you should also be looking at and timelining EDR logs alongside of it, because that'll give you the fullest picture. Any questions so far? All right. So let's start with event ID 4648. It indicates the lateral movement attempt has occurred. It is generated on the source, and it shows the target. It says nothing about whether it succeeded or not, only that it happened, only that the attempt happened from the host that this log is generated on. So here's an example one. And the different fields you want to look at in here are subject, which shows, this isn't right here, by the way. The first part shows the login type. That's not right. Sorry about that. But subject shows who attempted the lateral movement, which user account attempted it. The credentials is the account that was the one that was attempted to be used. The target server is the host that they tried to move to. Doesn't say whether it worked or not. Process information can sometimes show you the process that generated the logon attempt. Like, for example, I noticed when I was looking in our lab for scheduled tasks, it showed SCH task as the process that was doing it because I scheduled the task with that process. So that's what you would see on the host that's trying to move laterally. Here's what you would see on the host that they move laterally to. It's generated on the target, and it indicates that the login worked if you see a 4624. So logon type is the most important field in this whole thing when you're looking at 4624. In this case, we have logon type 2, but the most common for lateral movement from an attacker are 3 and 10. 3 is a network login, and it shows basically one-shot command execution, just sending a command to be executed, and that's it. Where type 10 shows RDP. If you see type 10 here for logon type, you can be 100% sure it's RDP. If you see type 3, you can be sure that it's a network logon for one-shot command execution. Network type 3s can happen from the same host to the same host in some cases, but that's not the typical scenario. So yeah, network information will show where it came from. Sometimes it's not there, but most of the time it is. And sometimes you only get the network address or only get the host name, which is annoying, but at least it's something. It'll show you where to maybe look. Detailed authentication information shows a little bit about like the method used to do the logon. Any questions on this? Okay. Oh, by the way, you get a logon GUID, which can be used to see what else happened during that session. So if this GUID was populated, you'd be able to throw it into your logging repository and see what else the session did, which is very useful. And that applies to type 3, type 10, any type. Here's the lateral movement methods I'm going to go over. RDP, PSExec, scheduled tasks, WMI, PS remoting using PowerShell, network exploits, and I'm not going to go over others, but others exist. So one of the easiest to find and one that's the most helpful to an investigator is an RDP logon for a bunch of different reasons. It'll show type 10, like I said, in this logon type here. So that's the way you can tell if it's RDP or not. The reason RDP generates so much evidence is it establishes what's called an Explorer shell, which means that there is special stuff that happens when an Explorer shell is established. It generates more evidence in a bunch of ways. It'll show stuff in like shell bags, stuff that involves browsing directories with Explorer. That will give you hints as to what the attacker was looking at in some cases. There's also an RDP bitmap, which is really interesting. It's not always generated, but when it is, it shows images that the attacker was most likely to see because RDP basically caches some images that it thinks it's going to show constantly, like a certain icon or something like that, that just to save bandwidth going over the wire. RDP is different from like a VNC in that the OS knows stuff about RDP sessions where VNC is just showing you an image over and over and over again every second. And one of the things that the OS understands about RDP is the bitmap cache. Images that are cached to save bandwidth but are useful investigatively to see what the attacker was looking at. It doesn't, like I said, doesn't always work, but it can. So look it up if you ever have an attacker that is using RDP. And like I said, shell bags are just, it shows directory browsing activities and shows what they might have been looking at. So process-wise, RDP is also noisy. If somebody logs into a machine using RDP and starts doing bad stuff, the process that will be the parent process of all the bad stuff will be explore.exe because RDP gives you that Explorer shell, and that is the shell with which you interact with the OS with. So you'll see explore.exe doing bad stuff. And if you see explore.exe doing bad stuff, most of the time you can assume that it involves a Explorer session unless there is something like process injection or DLL injection into Explorer, which happens, but not as much as Explorer simply doing bad things. And also, you might see RDP clip.exe. It can be used to move like files and data between the RDP session. So if you see that, that's what that is. Here's an example log from our lab that I generated myself using RDP. What I simply did is use the Windows Terminal Services client from one machine and used it to log into another using this account named Red that I made, which is just a simple user account that I generated for this lab. The only thing it ever did was this RDP session. And the thing that hints that this is RDP is the logon type 10 there. So always look at the logon type. Whenever you see a 4624, the first thing you should be looking at is logon type. And probably the second thing you should be looking at is where they came from and stuff like that, and who it is as well. Because you can use this information to look at other activity on your network from the same user. If they did anything, you can go to this host to see maybe what else they did. It's very common to see with an attacker that they establish kind of like a mothership or home base, which is a machine that they move out from in kind of like a star pattern to other hosts to do exploration. In a case like this, that would be something worth looking into. I would go and look what was happening around the same time as this login on the source machine, because it could be We know that it was being used by an attacker to generate this logon. We want to see where else they went and what else they were doing on that host, both from a process, file system, a lateral movement, event log perspective, everything. It could be that they were just daisy chaining between hosts. So they went from one host to another to another. In that case, it's less interesting. But what you would see is another force. If they were daisy chaining, you would see another 4624 on this host to see where they daisy chained from. And then you would just go to the next host. So chasing these down is very important in figuring out how lateral movement work. One other thing to keep in mind is logs can do what is so-called, they can be rolled, which means too many logs showed up in the file, and as such, it hit the limit, and now they rolled off and you'll never see them again, unless it's on unallocated file system or something like that. But that's out of scope for this. Anyway, let's keep going. Oh, any questions on RDP? What time do I got? Okay. Next one is PSExec. And this is a very common way to execute stuff on other machines on the network. It's great for doing stuff at scale. Let's say you want to deploy ransomware on 100 machines or 1,000 machines. PSExec would be a good candidate for that, just because you can do it in one command. You can infect, 1,000 machines if it's properly set up. One way to infect 1,000 machines would be to set up a file, on a file server somewhere that everybody can access, and then just send them a PSExec command to go download and execute this file. That's a very common way of spreading ransomware, and it's effective as well. And what you would see with that is basically a huge number of AV alerts, huge number of EDR alerts, and then if they did get encrypted, that would be very bad. All those machines would have to be reimaged essentially. So you never want to get it to that point, but it occasionally happens. Make sure your EDR settings are tuned up to not allow as much lateral movement as you can get away with. But if you make your policy too strict, users will start complaining and things will start breaking. So it's a fine balance. PSExec generates a network logon, much like everything else in this presentation, so the type 10 only happens for RDP. Type 3s happen for a lot of different things. So it says something about what the attacker was doing, but it's a lot less deterministic. It just says that they wanted to execute commands essentially, and that they did because, they got pretty far, I'll put it that way, because if you're seeing a 4624 for a type 3, it means the logon worked. It's possible for the logon to work and the command execution to not work. For example, if it was blocked by EDR or something like that, or the user doesn't have the rights to execute the command in the way that you tried to get them to execute it, that can also happen. In which case you would see this logon succeed, but the thing they try to do wouldn't have worked. And it's kind of hard sometimes to tell how that is. You can tell if it happened, though. If an EDR says, I blocked this, then you can safely assume it was blocked. Okay, PSExec can be run with a service flag, which will cause a new service to be started on the target host. There's a default name called PSExec svc.exe, which I'll show you, but you can also name it something else if you want. And if you did that, it would make the person investigating have to do a little bit more work, but not a whole lot, because they would eventually work out what you were doing, either through hashes or some other way. So it's common to see a large number of type 3 logons clustered together when that should be PSExec, not RDP, sorry. When PSExec is used, because if you execute multiple commands, sometimes it will log in once to execute each command, especially if you don't have some kind of interactive flag or something like that. A no Explorer shell is established. I believe there is a flag to establish it, but no attacker in their right mind would do so, I don't believe, because it doesn't get them anything really. And attackers don't tend to do things that don't win them anything at all. What it would do is open them up for more evidence to be collected, I believe. But I've never really even seen the flag used by an actual attacker. That's how rare it is. Like I said before, it's suitable for mass malware deployment. PSExec can copy itself and other files over the network when used. So if you tell PSExec, I want you to execute this other file for me, it will copy both itself and the other file over the network. And you'd see that in like PCAP if you had it. Here are some other event IDs you'll see if PSExec is used and is successful. You will see a service creation event with an ID of 7045. This Event handily is part of the default install of Windows and almost never rolls just because it's the log it's in. If you see this, you can infer that somebody executed a command with PSExec. We don't know what the command was, but we do know that the service was successfully started, which is 99.9% of the way there. So if you see this, somebody executed a command with PSExec, it was likely successful. You might also see these 736, and they're running and stopped. You can kind of infer how long it took the command to run, which isn't super useful, but it can give you tips. And whenever I'm timelining a host that has this log, I also include it just because it gives you a little bit, it'll tell you when it ended for one thing, which is good to know. Any questions on PSExec? Okay.
Hey, Kevin.
Yep.
Hey, I had a question. Earlier you said log rolling. Was that a way to, I guess, get rid of the event IDs in the logging system so they can't be seen?
No, an attacker wouldn't do it purposely, and most of these logs don't get rolled just because they're in the security log. But let's say you have a really noisy, let's say you turn on full process auditing, it will within the matter of a day roll the log, just because there are so many things happening on, especially if it's a server, there's so many things happening on the host that the default log size is so small that it's just going to maintain like a rolling buffer of event logs about processes. But for these, they don't roll as much. You don't have to be worried about it as much. For example, I've gone into hosts that were compromised 2 years ago, and they will still have logs like this, or a year ago, let's say. They will still have logs like this. But rolling is something to keep in mind for, let's say you have a ton of application logs, and there's also something writing to the application log constantly. You can safely assume it's been rolled. And you'll know when something's been rolled too by looking at the first log chronologically in it will tell you when it was rolled, because that was the first thing after the roll. Does that make sense or help?
Yeah, that makes sense. Thanks.
Yep. Okay. Let's keep going. So scheduled task, it also generates a network logon. And that makes sense because all it's really doing is sending an XML file, or basically an XML file over the network. And the XML file says a couple things about what's going to happen. It's going to say when to execute the task, how often, like whether it's recurring, what to do when the task is triggered. That will all be in that XML file. And thankfully, this XML data is usually retained in both the registry and event logs. So if somebody uses a scheduled task these days, it's logged pretty well. They have to give it a name as well, which oftentimes can wind up being an indicator that you can search from across the network. And if an attacker uses scheduled tasks on one machine, they're likely to use it on other ones. It's kind of like a personal preference type thing. Although there's some people out there that will use both PSExec and scheduled tasks as they see fit. I think it's worth mentioning that there used to be this old system called @jobs, but it's deprecated now. But if you're looking at a very old machine, there's these things called @job files that you'd have to look at, but it's kind of out of scope for this, and you should look it up if you're looking at a very old host, and it'll show you where to look on disk instead of the registry to find these. But the test data is written to the registry, and you can see it as long as it doesn't get deleted. But even if they do delete it, and they don't delete it in event logs, it'll still be there. So this is what a scheduled task log looks like. It is a 4698. A scheduled task was created, and this is part of the default Windows build. So you'll see this without having to do anything. And keep in mind, when I say default build, you can safely assume it'll be on every host, because nobody ever scales back their logging policy past the default to save space, because the default policy is really light on disk. It's not tracking processes or files or a registry. So the things that it is talking about don't happen very often. The closest would be like logons. If there's a long period of logon data and the host is very popular, that's when you might see a roll. But we're talking months or years it would take. So any questions on scheduled tasks? All right. Now we're getting into ones that are inconclusive in evidence. You'll see something, but you won't be able to make much of it, and it won't be very noisy, and it won't give up a lot of other stuff to key off of. You'll just see one little piece, and that's it, especially if you don't have EDR, especially if you don't have a cranked up policy. It is very conceivable that you will only see the 4, 6, 9, 8, depending on what they're doing. If they're playing mostly in memory, like they're just downloading and executing backdoors once, and that's it, and it doesn't write anything to disk, it's not persistent, then you're going to have a very hard time figuring out what happened with this if you don't have any visibility into processes. WMI is Windows Management Instrumentation. It's basically a system that lets you send scripts and retrieve data en masse to a bunch of different machines easily. It's just an interface to talk to the OS about what's going on a machine, basically. And you can also instruct the machine to do things. WMIC is the process I see people executing with WMI the most. And if you do use WMIC, the WMIC process can be used to register generate a command on another host in the network. But if you use it to do so, the malicious activity, the parent process for all the malicious activity is going to be this WMI PRV SE, just because that's the process that handles the commands that you send using WMIC on the target host. So this would be the parent process, and whatever bad stuff happens on the target host, this will be the parent process for it. So anything that's bad that happens there will be a child process of this, or it'll come from this itself. It doesn't generate a whole lot of evidence, like I said, especially with a default build, because default builds aren't tracking what's happening on the command line. So there's just not a lot. EDR is better here just because it's very sensitive to the system and it knows what to look for better, and it's just in a better position to say what happened than Windows in a lot of cases. You can sometimes see it happen on the command line, especially on the host that issued the command. If you're tracking processes like with EDR, you can sometimes get lucky that way. But that's it. Any questions on WMI? And everything that's here is related to WMIC. Okay, so for PowerShell, there's this thing called PS remoting, which is a way of executing commands on other hosts. You can get a session, like a command session type thing, or you can just execute once. This isn't enabled by default, so the only networks it really works in are ones that the admins have turned it on for whatever reason, or some kind of software has turned it on. And that's a lot of networks, but it's not all of them. So if this is turned off, it can't be used for lateral movement, because if lateral movement is getting execution on the machine and you need the execution to turn this on, you're basically SOL for this one. This also does not generate a lot of evidence, especially, again, if they're not interacting with the file system, if they're just doing stuff in memory, which is often the case with PowerShell, unfortunately. There's a lot that can happen just in memory with PowerShell, and it's often the biggest offender in this regard these days. If you use PS remoting to do bad stuff, it'll appear to come from this WMS or WSM prov host.exe. That'll be the parent process for the activity that came from the PowerShell PS remoting lateral movement. The last one here, and this one is very vague because it describes an entire class of vulnerabilities that can be used to execute stuff on another machine in the network. Back in the day, like when I got started, like 10 years ago, there used to be a ton of network worms that they'd be on the network, they would talk to a bunch of other hosts on the network, look for a network-facing vulnerability. Then if it decided that it saw it, it would exploit the vulnerability and then copy itself to the next machine for the process to start all over. And obviously, what would happen is the network would be completely saturated within minutes, typically. If the network owner didn't take care to make sure that this couldn't happen. And there's lots of ways to mitigate it, but what's happened recently, let's say, I guess past 10 years, is the network vulnerabilities are drying up. There's not that many of them, and they're very boutique, especially in Windows. There's basically none of them left these days. They get patched quickly, and when these self-propagating worms were around, it was obviously a huge problem. So I think the people designing the operating system got better with not introducing new vulnerabilities as they patched out the old ones, and that's kind of how we got to where we are now. But back in the day, like with, let's say Configure was the classic one, it would simply just take over the process that it exploited. It was often with like RPC calls and stuff like that. So that process would be the one doing all the bad stuff. And it wouldn't really involve authentication because of how out of whack the whole exploitation was. It was able to do bad stuff without generating a new logon, just because of how the software worked. But again, like these days, it's rare. You'll sometimes see it, but it's a once in every couple of years thing. And it's in the severity of these tend to be less and less as time goes on too. All right, so that's that for network exploits and network worms. Any question on that one? All right. So let's go over the lab stuff. You will have a link to a bunch of, well, it's a Google Docs. There's questions in here. There are 5 different scenarios and 5 different tabs. All you have to do is simply match the tab to the scenario. So if you think this is WMIC lateral movement for 1, just write that down. And then at the end, you go over the answers and see if you were right. Make sure to look back in the presentation. It should be fairly easy to see which one is which. It's not supposed to be super hard, but it is supposed to show you that you pick something up from this. And that was really the goal here, that you have something to go forward with and you use in your day-to-day. So I think that's that.
You got anything else for us, Kevin? Closing thoughts. What's the biggest thing someone should take away from today's workshop?
If you have the time, go try it yourself. Set up a VM, and so 2 VMs, and keep clearing the event logs, and then use these various techniques to log into the other machine, and you will be able to reproduce what I've shown you here. If that's too much, just, try to absorb what you can from this, and I guarantee if you're working with event logs in the future and there's lateral movement, it'll help you for sure. You'll notice things about it that you might not have before if you weren't familiar with these things.
Awesome. Just wanted to thank everybody for joining today's session. We will be following up with all of you guys with that Google Sheet, with the lab challenge that Kevin put together, and we'll provide the slides as well if you need a guide to follow along with what he talked about throughout this session. But if you've already signed up for the bi-weekly, you should have this on your calendar every 2 weeks. If you don't, feel free to let me know and I can get you added to the invite. We also have these sessions on demand on our YouTube channel and on our website. If you want to access the giveaway to any episode, they're linked only on the website, not on YouTube. So just keep that in mind. But stay tuned. We're going to have a Q&A next time in 2 weeks with one of our customers, most likely, and kind of get more of a detection engineering take on how they got into the field and just ask them a lot of good questions. So if you want to ask questions, you want to come to more of a discussion session, definitely join in 2 weeks. Otherwise, if we don't have any other questions, I don't think I see anything, but we're really glad you guys joined. Have a great rest of your day. Thanks so much, Kevin, for this awesome session. And we'll be following up with all of you guys, and I will CC Kevin on the emails as well, so that if you do have any questions to follow up with, anything more technical, feel free to tag on there. So thank you, everybody. Have a great rest of your day.